Hi, I'm Valley from Greenwood Solutions. This week's presentation is part one of a two-part series on energy storage and sizing. So we're going to go into quite a bit of detail of what's required to actually get an energy storage solution to the customer. Why would a residential customer connected to the grid want to purchase an energy storage solution? I want to tell the electricity to go and get, I want to show the world what I can do. I have the money to do so, example a holiday house. I want to save some money. I want power 24/7 despite potential grid failure, possibly environmental concerns. The drivers are psychological and financial. Determining the driver for the decision for the customer to go down the road of energy storage is crucial. Let's talk grid failure. The grid fails due to an unreliable supply. Certain loads must be serviced at all times. If decision to adopt energy storage is based on grid outages, financial concerns, questions are asked is, what will I lose with no power? Energy storage system options are the basics. Batteries, just there when the grid fails. So UPS, emergency backup. So by UPS I mean uninterrupted power supply. Batteries are there when the grid is available. So we're talking about tariff optimization of possibility. Batteries with the grid, and when the grid fails, both backup and optimization. What does your customer want? What do they think they need? What do they actually need? And what are they willing to pay for? You've got to determine the customer's motivation. Is it mainly a psychological driver or want? Is it mainly a need, i.e. energy at all costs? Or is it financial? Cost of storage pays for itself, reduces demand charges, business can continue operating if the grid fails. Basically, you have to establish their existing solar status. Do they have solar? This is a yes-no process. If they have solar, you may need to upgrade. If no solar, you need a solar system. Next thing is to determine what their energy consumption is. Not only the average daily load, not only how much they consume in a 24-hour period, but when they consume it. So you ask the customer to look at the average daily load, which they can find from their electricity bill. Look at the bill or estimate on the amount paid per quarter. Determine when energy is being used. Ideally, you look at the interval data, so you can make a request. An authority to act document can help a lot. Determine the nighttime, daytime split of their energy consumption. Ask the question, is grid disruption an issue? And the other thing that tempers the design of an energy storage system on the grid is the tariff the customer is actually experiencing. What are the customer's tariffs? How does the tariff relate to the consumption profile? A fairly accurate assessment can be made without interval data for the purpose of a preliminary costing. Let's say the majority of energy is used outside of solar production hours. These hours correspond to the peak tariff rate. In other words, solar cannot directly address these loads. The load outside of production hours is 10 kilowatt hours. Let's assume a battery charging efficiency of 85%. So from the energy storage, we will need approximately 12 kilowatt hours. In other words, 10 kilowatt hours divided by 0.85. We really hope you enjoyed part one of a two-part special on energy storage sizing. Look out for part two coming soon. Hope you enjoyed part one. See you in part two.